Problem sheet 8, question 1. Consider the activities on arrows diagram below. Do a forward and backward pass to find the critical path. Draw the corresponding activities on nodes diagram. Give the float for each activity. So we'll start with question A. Do a forward and backward pass to find the critical path on this activities on arrows diagram. So to do a forward pass, we will find the earliest time we can reach those points for each node, starting from the very first node. And that's first node there are no arrows before it, so we have not completed any other arrows. The earliest time we cannot complete anything is time 0. The next node we will look at, this node here, we can analyze this node because every arrow going into this node we have already analyzed, for example here. So the earliest time we can reach this point is the earliest time we can have completed activity A. Activity A takes 5 time units, and we can only start it at time 0, so the earliest point we can reach here is at time 5. Now which node do we go to next? We cannot go here because we would have to analyse this node first, and so we will analyse this node here. What's the earliest time we can reach this node? Well, we need to have completed B. In order to start B, we needed to have reached this node here, and the earliest time we can reach that node is at time 5. Then we need to complete B, which takes 6 time units. So the earliest time we can reach this node is at time 11. Now we can analyse this node here. What's the earliest time we can reach this node? Well, either we need to have reached this node and taken this dummy arrow, which takes 0 time. So it's either going to be 11 plus 0, or we need to have taken this arrow here, C, which we can only start after reaching this node at time 5, and C takes 4 time units, so it could be 5 plus 9. Both those things need to happen, so the earliest time we can reach this is the latest time that we have completed both of these, which is 11 plus 0 or 5 plus 4, so that would be 11 plus 0. Next we will consider this node here. This takes 10 time units, and we needed to have reached this node before starting activity E, and so the earliest time we can reach here is 11 plus 10, which is 21. How about this node here? This will be 21 plus 10, 31. We cannot go to this node yet because we need to have analysed this node first. So let's analyse this node. That will be 11 plus 7. So the earliest time we can reach there is at time 18. This node now, this will be 18 plus 15, which will be 33. We can now analyse this node here. Now to reach this node, there are 2 dummy arrows. So this will be 18 plus 0 or 31 plus 0. The earliest time we can reach those is the maximum out of those, which would be 31 plus 0. So the earliest time we can reach this is time 31. Now we can reach this node. There are 3 arrows coming here. So this will be the maximum between 31 plus 2, 31 plus 4, or 33 plus 7, which will give us the earliest time to reach here as 40. And finally, the earliest time we can reach this node, which is the end of the project, is time 40 plus the duration of k, which is 10, and so 50. We have now completed the forward pass, finding the earliest possible times to reach each of these nodes. We shall now start with the backward pass, finding the latest possible times we can reach each of these points without delaying the project. As the name suggests, a backward pass, we will start at the end. What is the latest possible time we can reach the end of the project without delaying the project? Well, the earliest possible time we can complete the project in is 50, and so without delaying, the latest possible time will also be 50. What is the latest possible time we can reach this point in the project? Well, in order to keep this as 50, this takes 10, this can only be 40. Now where do we analyse next? We cannot analyse this node yet because the latest possible time to reach here will affect both this node and this node. One of those we haven't analysed yet. So we need to have analysed this node first. What's the latest possible time we can reach this node so that we don't delay this point here, 40? Well, the difference between these nodes is the activity I I takes 4 time units, and so the latest possible point we can reach this point would be 40 minus 4, which will be 36. Now we can go ahead and analyse this node. We don't want to delay either this or this, the two children nodes of this node, the two nodes that you can reach by following arrows from the node we are analysing. So if we don't want to delay this node past 40, how do we get there? By following activity H, which takes 2 time units. Then we wouldn't want to reach this node past 40 minus 2, which is past time 38. How about this node? We don't want to delay this past time 36. We have to take this dummy node, which takes 0 time. So we don't want to delay this past 36 minus 0, which is time 36. And so any time past 38 or past 36 will delay the project. And so we don't want to delay this past time 36. We can now look at this node. We want to reach here by time 36. G takes 10 time units, and so we don't want to reach this node any later than 36 minus 10, which would be 26. Now we cannot analyse this node yet because we haven't analysed this node, and we cannot analyse this node as we haven't analysed this node. So let's consider this node. The latest time we want to reach here would be 40 minus 7, which would be 33. So analyse this node. The latest time we want to reach this node would be the minimum between 36 minus 0 and 33 minus 15, which will give us 18. Finally, we can analyse this node. The latest time we want to reach this node will be the minimum between 26 minus 10 and 18 minus 7, giving us a latest time of 11. Now we can analyse this node. This would be 11 minus 0. This node, this would be the minimum between 11 minus 6 and 11 minus 4, giving us 5. And finally, the starting node, this would be 5 minus 5, which would be 0. And we know we've done right when we finish on a 0. So that has completed the backward pass. Now we wish to find the critical path. Now an activity is on our critical path when 3 conditions are true. So for example, K is on our critical path because the node at the end of K, the earliest and latest start times are equal. The node at the start of K, the earliest and latest start times are equal. And the duration of K is equal to the difference between the earliest times at the end of the node and the earliest times at the start of the node. And so we can begin highlighting all the activities on our critical path. And so our critical path is the activities A, B, the dummy activity, which is a dummy activity, so we don't need to discuss, D, F, J, and then K. The next question is asked us to draw the corresponding activities on nodes diagram. So this is an exercise in converting between the two different diagrams. So our activities on nodes diagram, every activity is a box. Set out like this. We can name the box, for example, A, that is the label of our activity. The duration of the activity will go in the bottom left-hand corner. The earliest time we can start A will go here. The latest time we can start A without delaying the project will go here. And then finally the float of A, by how much can we delay A, will go here. And that will be the latest minus the earliest time. And remember, we always need to start and end with a dummy start and end activity. This dummy activity will have duration 0. The only activity we have without any prerequisites is A. For example, B and C both have A as a prerequisite, and so on. So the only activity that will emanate from the starting activity will be activity A with a duration of 5. Both B and C have A as a prerequisite, so activities B and C will emanate from A. Both D and E have C as a prerequisite, but due to this dummy arrow here, they also have B as a prerequisite. Like so. G only has E as a prerequisite. F only has D as a prerequisite. I has both D and G as a prerequisite. H has G as a prerequisite. J has F as a prerequisite. K has H, I and J as prerequisites. And finally, we always have to end our project with a dummy end node, which has duration 0, and we will connect any activities that are not themselves prerequisites of anything else to the end node. So this will be the activities on nodes diagram all set up. We now need to do a forward and backward pass in order to find the float for each activity. Doing a forward pass, we'll start at the start and we'll find the earliest starting times for each activity. So the earliest time we can start the project is at time 0. The earliest time we can start A is going to be 0 plus 0. The earliest time we can start B is going to be after A is complete, 0 plus 5. Similarly for C. The earliest time we can start D, we need both B and C to finish. The earliest time B can finish is 5 plus 6. The earliest time C can finish is 5 plus 4. We need them both to finish, so the earliest time will be 11, 5 plus 6. Similarly for E. For F, we need D to have finished, that's 11 plus 7. For G, we need E to have finished, that's 11 plus 10. For I, we need both G and D to have finished, so D will finish at 11 plus 7. G will finish at 21 plus 10. We need both of them to have finished, so it takes the maximum out of those, which will be 21 plus 10, which will be 31. J needs F to have finished, that's 18 plus 15. H needs G to have finished, that's 21 plus 10. K needs J, I and H to have finished, so we'll take the maximum, the latest, out of the earliest times each of all these can finish. So we'll take the maximum out of 33 plus 7 for J, 31 plus 4 for I, and 31 plus 2 for H. That would be 33 plus 7, 40. And what's the earliest time we can end the project? We need K to have finished. The earliest time that can happen is 40 plus 10, which is 50. So that's our forward pass. We will then do a backward pass to find the latest times we can start each activity. So we'll begin at the end. The latest time we can begin the end activity without delaying the project will be the same as the earliest time we can end the project. That is 50. For K then, we want to take this 50, the latest time we can end the project, minus the duration of K. That would be 40. For J, we take 40 minus 7 is 33. H is going to be 40 minus 2, it's going to be 38. I is going to be 40 minus 4, that's going to be 36. F will be the latest time J can finish, which is 33, minus the duration of F, which is 15, it's going to be 18. For G, we want to consider the latest time H can start and the latest time I can start. So we want to finish G at the minimum of those. We want to finish G at least at time 36, and G takes 10 time units. And so this will be 36 minus 10, which will be 26. Similarly for D, the latest time I can start is time 36. The latest time F can start is time 18. So you want to make sure we finish D by time 18, the minimum out of those. And D takes 7 time units, so it will be 18 minus 7, giving 11. For E, we want to finish E by time 26 so that G can start. 26 minus 10 is going to be 16. For C, the latest time C can start, well, we want to finish C by the latest time D or E can start. The minimum of those is 11. So we want to finish C by time 11 minus 4, which is the duration of C, would give us 7. Similarly for B, we want to finish B at the latest time D or E can start. That would be 11. So we're going to finish B by 11, and it takes 6 time units to complete B. So the latest time B can start is 11 minus 6, which is 5. For A, we want to finish A by the latest time either B or C can start. The earliest of those is B, which is 5. So the latest we can finish A is 5. So the latest we can start A is 5 minus 5, which is 0. So the latest time we can start the project without delaying it is 0. So that would be the backward pass. The float for each activity then, that is how much leeway, how much slack we have in starting each activity. That is going to be the latest time we can start the activity minus the earliest time we can start the activity. So we can just fill those in for every activity. 0 minus 0, 0 minus 0, 5 minus 5, 7 minus 2, and so on. And that answers C, give the float for each activity. A further thing we can do to check our work here is we can read off the critical path, and we should have exactly the same critical path as we had for our activities on arrows diagram. So recall the path for that was A, B, D, F, G, K. And for the activities on arrows diagram, the critical path would be all the activities with a float of 0. Which would be A, B, D, F, J, K. So we know we've used 2 different methods to come to the same answer.